All right, good morning, everybody. I'm Sam Madden. I'm the organizer of this session, Systems That Learn. So I'm going to just give a few little introductory remarks about what Systems That Learn means, and then I'll hand it over to some of our other presenters. The organization for today, we're going to have a series of short talks that'll take us till about 11, and then we'll do a panel at the end. You're welcome to ask. What do you need? You guys okay back there? Okay, and then we're going to do a panel at the end. But you're welcome to ask questions as the session goes on. Everybody's going to leave a few minutes at the end, hopefully, for you to ask questions. But the panel will be another opportunity for you to kind of probe us about what you think is, or what we think is the most interesting stuff happening in computer systems and learning. So, so our speakers today are Mohammed, Manya, Tim, Dina, and me. And I rendered all of us. I guess I've been playing too many video games with my son because I rendered all of us as systems fantasy warriors. I think if there's one thing that AI is going to have as a legacy, it's, I don't know whether this generative AI thing, there's anything real to it, but like the ability to create images is just incredible. I can say like, create barbarian female warrior of networking, and it renders this picture like this, of like this like, awesome warrior smashing networks, it's just amazing. So anyway, I thought that was pretty funny. Okay, so let me just talk a little bit more seriously. Computer systems, what is computer systems? Fundamentally, computer systems, what we mean when we say this is developing these reusable abstractions that we all know and love that run our computers. So these are databases, file systems, operating systems, networks, right, that allow us to sort of hide all the complexity of our computers so that we can write these, really incredibly powerful programs that without having to, think about how the assembly instructions that we want to write or the bits that we want to transmit over the network, right? And the kind of the lesson of computer systems is that, if you were to build a system from scratch for every use case, we would never make any progress, right? So we have to build these layers. We build up these layers of abstraction that allow us to, as programmers, not think about all the complexity that we're sort of building on top of. And that's really what computer systems is about. And we're going to hear today from people in different areas of computer systems about how machine learning and artificial intelligence is changing the way that they think about building computer systems. And the trend here, and this is a lot of what you're going to hear today is driven by a trend that, you may have seen other people at sessions here put up, which is just the sort of inexorable growth in the amount of data on one hand on the bottom, and on the other hand, this sort of stalling out of the amount of computational power that we have. And these two competing trends, where we've got computers that are not getting faster, is what we show on the bottom, and this just insane volume of information that we need to process and make sense of, are really driving a lot of need to develop new specialized computer systems that are ever more powerful. And that, of course, is coupled with this recent, what I call AI tsunami, right? Just this flood of new interest in these especially generative AI models, but all sorts of machine learning models that are driving a need for new computer systems as well. Okay. And one of the lessons of computer systems that I think is important to remember is that it's often the case that if you're willing to build systems that are specialized to particular use cases, you can get better performance. Okay, so this is the analogy here is the race car, right? If you're willing to build, a specialized car for a specialized environment that only goes on, a little 1 mile, track, you can build a way faster car than if you're trying to build something that's designed to operate on city streets, right? And the lesson holds in computer systems too. These are two examples from databases and networks, but in databases, if you're willing to build systems that are specialized for certain settings, like you want to build a system only for analytics that like processes really large volumes of information, you can build a much better system than a generic system like what Oracle or Postgres or something you might be familiar with. So the reason that these companies like Snowflake are worth billions and billions of dollars is because they built these specialized system for database analytics that's just way better better than a conventional system. And the same thing holds in networking, right? If you're willing to build a network that's specialized for a data center or specialized for a cellular, for cell phones, or as we're going to hear from Manya, maybe specialized for machine learning workloads, you can just build a network that's way, way better and faster than the conventional general purpose network. Okay, but the problem is that each of these specialized systems is like a big engineering effort to build, and each one of them only addresses some of the use cases. Okay, so one of the themes that you're going to hear a lot about is, can we use learning to specialize the systems that we build? So can we, instead of having to engineer each one of these systems, taking maybe a decade of person years to engineer each one of these things and roll it out, can we leverage the power of machine learning to help us to automate the construction of these kinds of specialized systems? Can we use machine learning to actually specialize the systems themselves? And we've been calling this instance optimization. The reason we call it instance optimization is you think of this as you've got a database instance, like or a network instance. Can you use construct a specialized version of that using learning? Okay, and so this is maybe what we mean when we say learn systems. These are systems that automatically adjust to the given data and workload. They do it beyond what a human can do. We're not just tuning a few knobs, but we're trying to really optimize or even re-engineer the whole system internally. And the components themselves often deeply embed machine learning. So you're going to hear from us today about a bunch of different things we've done in this space. We built these learn systems that leverage machine learning internally to just get better performance and act in these kinds of specialized ways. So for example, one thing you'll hear about is, or one thing that we've been doing a lot is using machine learning to replace the query optimizer inside of a database system. And what we've been able to show is that these learned query optimizers are able to generate much, much more efficient programs, that is plans for SQL queries, than what you could get out of a conventional sort of optimizer architecture. But you're going to hear about a bunch of these things from Tim and Mohammed and others today when they talk. The other aspect, of course, of machine learning is this, or systems that learn, is building systems for learning. So there's using learning to optimize systems, but then there's also using systems to make machine learning better, right? And these things are sort of duals of each other, so I've kind of tried to show that on this diagram. We've got these specialized systems for learning. And these are typically purpose-built systems. They might themselves be sort of specialized through learning, but they're typically purpose-built systems. They're optimized for machine learning, or that use learning as a part of some kind of novel system. So you're going to hear about a bunch of these things today. Manya is going to talk about her work on networks that are specialized for machine learning workloads. I'm going to talk a little bit about how we can build database systems that operate over large archives of video. So you're going to hear these about several different systems that are sort of in this space. But we've been working as a group, the people you're going to hear from today, and all of us at CSAIL have been working on many of these different kinds of ideas around building systems that are optimized for machine learning themselves. Okay?